Hi guys, this is Matt's Firm, and today we are going to start with some limits. Well, limits are the basis of differential calculus, so it's very important to learn them first before we go on with differentiation. So I define a function f of x is equals to x by x. This might seem a silly function, as you might say that x by x we cancel them and we get just 1. But that is not the case here. This is not defined at 0, as 0 by 0 is what? Not defined. So this is a nice function to start with limits. I write this again in a smaller font. Fx is x by x. And remember, if you know about domain and range, the domain of this function is all reals minus 0. That means that the values that x can take is not any value, that is not all reals, but except 0. That is, it can't take 0 in, but any other value it can take. So now I'll graph this function, and remember that this function will almost always be positive except this where it is not defined. So this is our point of concern. I draw a special line to make us remember now and again that the function is not defined at this green line. So when we'll take some values of x and we'll get the values of f of x. So when we take x is 1, then f of x is 1. X is 2, f of x is still 1. And no matter what value we take, we get 1 except 0. At 0 this is not defined, so I draw an empty dot here and complete the graph. Now the question is the limit as x approaches 0 of x by x is. Now here we can't say not defined. Just because x is equals to 0 does x approaches 0 does not mean x is equals to 0. X is just as close to 0 as it can be. Suppose first our x is here and we push this to the left, or suppose it's here, we push this to the right until we get, say, this much close. So when x goes near and near to 0, the function is still 1. But when it just reaches 0, the function is not defined. So the answer to this limit is 1. Let's try another one. Our function here is 1 over x. When you are still a beginner, it's a great help if you can draw the graph of the function before proceeding. And I will draw the graph for you. Well, the 1 by x is a standard graph, that is a pair of hyperbolae like this. Now the question is the limit as x approaches 0 of 1 by x is. So now we'll use our graph to check this out. X approaches 0. Now at x is equals to 0, this function is not defined, as 1 by 0 is not defined. So our x is not equal to 0, but it's just as close to 0 as it can be. Say it is 0.001 or 0.0001. What's the problem with the pen? 0.001, 0.0001. And as you can see, if I take this point here, the x, and push this to the left, the value of the function rises slowly, but then it rises extremely. So when x is just 0, the answer of this function is infinity. But this is not a complete answer. We have to take a look at this branch of this graph also. So when it's just 0, or when it's minus 0.000 something, then it is minus infinity. The function is minus infinity. So here we get minus infinity, here we get infinity. So what should be our answer? Is it infinity or it's minus infinity? And remember, our question was the limit as x approaches 0 of 1 over x is how much? So in this case, the limit is not defined because we can't give two answers for a limit. Remember, a limit may be defined or it may not be defined. So in this case, we may make it defined by specializing or specifying something. See, our question earlier was x approaches 0. Now we say x approaches 0 positive. I'll tell you the meaning in a minute. This is our graph. I'll just make the positive branch of the graph. And x approaches 0 positive means x approaches 0 from the positive side. That is, we push this point to the left. We don't push this point to the right. We just have to take care of this one now. So now the answer would be infinity. And if we had taken it negative, x approaches 0 negative, then the answer would have been negative infinity. Negative infinity. So that we come to know that limits may be defined, may not be defined. So we take another example of a limit. Limit as x approaches 0 of 1 over x square. Now that looks a bit like the previous one, but this limit is defined. I draw the graph. This is also a standard curve. That's the graph. So this is the graph of 1 over x square. So now we need to get x as close to 0 as we can. We take x, say 5, then push this leftward. See the function here values this much. Then as we push this point, say here, then the function rises up to this extent. And then when it's just 0, the function would be infinity. But remember, we have to examine the negative branch of the curve also. This negative one is left. We push this point to the right. When it's just 0, first it comes here, the function is here, then here, then here, then here. It rises up and it is again infinity. So the answer to this limit is infinity. So this limit is defined. We recall our previous two limits that we have done. Limit as x approaches 0 of 1 over x is equals to what? Not defined. And the limit as x approaches 0 of 1 over x square is just infinity. So this 1 over x and 1 over x square, just a bit difference, but here the limit is not defined, here it's infinity. Because here the graph is discontinuous. Here also it is discontinuous. But here one branch is going towards the negative infinity, one is coming from the positive infinity. But in this case, in the graph, both the branches going towards positive infinity, as 1 over x square is a function which is always positive. It can't get negative value. So the function was defined, not defined at 0, but still the limit was defined. The limit was infinity. So that's how we learn that limits may be defined or may not be defined. Even if the function is not defined, the limit may be defined. And if the function is not defined, the limit might be not defined, as in the case of 1 over x we saw earlier. So we'll do just that today, and we'll learn some more limits in the next video. Bye till then.